Good afternoon, everyone, or everyone who's in my time zone, and welcome to everyone else, wherever you're coming in from. Welcome to this eighth session in this series, Geometry, Cosmology, Spirituality. Today we're going to continue looking at the golden ratio. And we're just going to look at a small aspect of it before we draw another small diagram, and then I'll continue in 2 weeks' time with, I think, one last one about this, how the golden ratio can be understood to apparently show itself in the Great Pyramid. Now that'll be in 2 weeks' time. Now let's begin with this one. Now, I hope you're feeling awake for the moon. I often have a bit of trouble sleeping around the full moon. Everything seems to be quite energetic around this time. Now, in the last session, I showed this doorway. This is the doorway into the sacristy in Wells Cathedral. And I talked about how its off-center position within its bay, so between these two pillars here, its off-center position is at the golden section. Now, the golden section being a particular cut of a distance into a smaller part and a larger part, which has this relationship of 1 to 1.618. That's the numbers associated with the golden ratio. Now, what I talked about in the last session, I associated this with Plato's divided line and the idea that passing through these doorways that are at the golden section look as if they possibly have some kind of symbolism associated with an ascent from one level to another. Now, I think another thing I mentioned a couple of weeks ago was how this sacristy, the back door of the sacristy, is also at the golden section of its particular stretch of wall. So we'll look at a ground plan of that shortly. Now, let's take a look at this actual ratio, the way that it would be expressed mathematically. Now, if you're not into maths, don't worry, I'm going to actually go through this very slowly and simply, so you will be able to understand it in about a minute from now. Now, the square root of 5, which is that tick and a 5, the square root of 5 plus 1 divided by 2. So that is what gives us this number, 1.618033. It goes on to many decimal places, an indefinite number of decimal places, in fact. Now, let's look at this. Let's sort of work our way backwards so that we can understand what's going on. First off, I'll put in this number above the square root of 5. This is the actual number, if you were typing numbers into a calculator. This is the number which is the square root of 5. Now, it goes on to an indefinite number of decimal places, so I've just put it to 3 decimal places, 2.236. Now, the square root of 5 is quite simply the number which, when multiplied by itself, makes 5. So 2.236 multiplied by 2.236 equals 5. Simple as that. Now, this square root of 5 is essential if you want to get the golden ratio. Now, let's look at this. Let's see, first I'm going to take away that divided by 2. So we're not dividing this by 2 now. We're just going to say the square root of 5 plus 1, or 2.236 plus 1 is obviously 3.236. So that's what's on that upper line of the formula. Now, because it's not divided by 2 at this point, what it's equal to is obviously 1.618 plus 1.618, because obviously when we divide it by 2, you just get 1.618 on its own. Now let's go further with this and take the 1 out as well. So if you now look to this area here, I'll highlight one of these ones. I'm going to take that 1 away because obviously I've taken it out of the formula. So I'm going to turn that into a 0. So now you actually see what the square root of 5 is and how it's very connected to these numbers within the golden ratio, because the square root of 5 is quite simply 0.618 plus 1.618. Now, there's a great significance with these two numbers. And as you can probably see, they're different to each other by a total of 1. And this is part of this, I suppose, importance and significance of the golden ratio, that it always brings you back to the 1. If we take the number 1 and we multiply it by 1.618, obviously we'll get 1.618. Whereas if we took the number 1 and we divided it by 1.618, we'd get 0.618. Now, this is the only number where this particular thing happens, where you sort of multiply, increase, or divide, decrease, you end up with this difference of 1. So that is part of this mathematics of this doorway. Now, if I'm going to be really honest, it's actually at a very high numbered rational approximation of the golden ratio. It's actually, well, you can look at it as being two different ones, either 898 over 555 or 900 over 556. Now that's all in the book. So that's a high number approximation, and it gives you 1.618. Just it's not exactly the golden ratio to many, many decimal places. Right, now we're looking at the ground plan of Wells Cathedral with this pyramid triangle. I've showed this, I think, in the second episode of this series of talks. Now, the one I showed in that one, I focused on a particular type of pyramid triangle that is made up of rational numbers. It has a base of 11 and a height of 7. And this is the one that's used in the amazing diagram that was somehow envisioned by John Michell back in 1970. Now, like I say, more about that in the second edition of this of these talks. There is another virtually identical pyramid triangle to that one I just described, and we're going to look at the triangle in that form in this particular instance because these two different pyramid triangles are so similar that they can be used as if they're one and the same triangle. And so that's what happens in the design of the cathedral with the use of this pyramid triangle. Now, it's a golden ratio pyramid triangle, and we can look at it like this. If this half the baseline is 1, then the sloping edge is 1.618. Now, what we're looking at here is the sacristy area. This is the sacristy, and that doorway we were just looking at, which is at the golden section of its bay, is this yellow area here. So let's get a photo of that up. So you see these pillar bases here. That's what's there. So these red lines are sort of culminating and marking those pillar bases. So you can see how the middle axis of the doorway is at the golden section between here and here. So there you have the lesser to the greater. So you could say either that if this is 1, this is 1.618, or you could say that if this is 1, the whole thing is 1.618. Now, there's a bit more to explain about this back door. It is at the golden section, or it uses golden section mathematics, but it's also offset in relation to the golden section. So it gives you yet another ratio, which is very important within the cathedral. But take a look at this 1.618 line here. It goes right through that doorway. And also this line here, which is another significant one within well, an area of the cathedral up here, which is the second level. This one is the golden section of the base. So if this is 1, this is 1.618. And this one divides the doorway area very precisely into 1 to 2. When I first sort of noticed this line going through the doorway off center, I wondered if it would be golden ratio, but it's not. It's actually, it divides it as 1 to 2. So it's really the, it gives a particular musical ratio, a 3 to 2 musical ratio. Whereas this red line is essentially giving you the 2 to 1 ratio because it divides the doorway in half. So you have these two main musical ratios with these two lines. Now, the other thing that I want to show you is that arithmetic, that formula we were looking at earlier for the golden ratio, which is expressed on the west front of Wells Cathedral. And let's take a look at this formula again. So I've written it just slightly differently this time. I put the square root of 5 plus 1 in brackets, and then divided by 2. So it's the same thing, just written in a slightly different way. What I'm going to do with this line is imagine that the line is square root of 5 plus 1 in length. So this here is the square root of 5, and then this is 1. So if we revert to the numbers that I mentioned earlier, that long segment of line is 2.236, which is root 5, and then the shorter area of line is 1. So the square root of 5 plus 1. Now the next bit, divided by 2, well, we need to divide the whole of this line into 2, like so. And so what we can then say is that on one side of the line, we have 1.618 here. Here is the golden section. So there's the lesser part to the greater part. Now, if we do an equivalent sort of mirror symmetry on the other side, like so. And there we have the 1.618 on the other side. Right, now keep your eyes on those three lines there. And I'm going to fade in the west front of the cathedral here at Wells. So as you can see, that appears to be the positioning of the doorway. So here again, we have doorways which are marking the golden section, just like the sacristy front door and back door. So obviously going from the outdoors into the world of prayer, it's another significant doorway, taking you from one state inwards to another, you could say. Now, having said all of this, all the stuff I've been saying about over the last few months about the rationalizing of irrationals, that is actually what happens here, because it's actually Fibonacci numbers that are used. If you look upon each half of the cathedral as being divided into 8 units, then those 8 units are divided up into 5 and 3, and they're consecutive Fibonacci numbers, 3, 5, 8. Now, Fibonacci didn't write his book about, or that mentions or that alludes to what we now call Fibonacci numbers until after this cathedral had been designed. So this really just goes to show that geometers don't just find out about things through reading about them. It's part of a whole practice, because Fibonacci himself would have found about them somewhere, if I found out about them somewhere. But there is actually an Indian mathematician called Pingala who wrote about them, I think about 200 or 300 BC. So it's old knowledge, and it's not just something that has been known about since Fibonacci wrote his book that alluded to them. Right, let's draw. I'm going to de-share my screen to say hello. Right, welcome everyone. Thanks for coming. And I'm going to switch my drawing camera on. Now, I've got a piece of A3 paper here, but that's really to stop the glare of the light, because it can affect what's then shown on the paper. But I'm only actually going to be drawing on a piece of A4. Now, obviously, if you have a piece of A3, sorry, it is A3, right? I think I just called it A5. Sorry, A3 paper here. A4, this is what I'm going to be drawing on. So let's prepare the page. Now, I'm going to begin by taking my ruler, and I'm going to measure 5 inches down. So I've got 0 on my ruler up at the top of this landscape piece of A4. And I'm going to make a little mark 5 inches down. This is just sort of laying out the paper. I've made a little mark down there, and I'm going to do an equivalent mark down here. And I'm going to use this as my line I'm going to draw on. Now this is it's a construction line. We'll use some of it, so that's why I haven't done it very strong, but hopefully that's strong enough for you to see. Right, now to get the radial measurement that we're going to work with, I've got 2 inches. Now, having got 2 inches as my radial measurement, I'm now going to place my ruler so I've got 0 on the edge of the paper. I'm sort of aware that perhaps you can't quite see the edge of my paper because of the brightness of the light. So as you can see, 0 there on the edge of my paper, and I'm going to place the point of my compasses I mean, you can put a dot there. Perhaps I'll put a dot there. On 4.5 inches. Now, the reason why I'm doing this is just to center the diagram in the page. So it might seem like slightly obscure measurements I'm giving you here, but it's just so that it sits centrally within the paper, what we're going to eventually draw. Right, so I'm going to place the point of my compasses in that 4.5 inch. Oh, sorry, actually, sorry. Oh my goodness, sorry, I've got that wrong. In fact, no, I haven't. Sorry, no, I haven't. Just let me check my diagram. Yes, yeah, got 4.5. Thank goodness for that. Okay, right. So with the point of my compasses, 4.5 inches that way, I'm going to do, well, similar to how we started last week. I'm going to draw an image of the rising sun to remind us really that all geometry is essentially about the revealing and I suppose you say the revealing of the illuminating light. Now, with the point of the compasses at that position there, I'm going to do a quarter circle and give myself an image of a bird opening its wings in that image of the rising sun. Now, these two intersections are what I'm going to use next. This is the same thing we did 2 weeks ago as well. Um, I'm going to line my ruler up with the middle of that cross and that point there. I'm only actually going to draw within the semicircle. So this is like how we did it 2 weeks ago as well. And I will harden up some of these lines, but not all of them. So this one, I am actually going to harden this one up a bit later on, but for now, I'm just going to do it faintly. Now, with the same radial measurement on the compasses, as you can see, I'm uh, placing the point of my compasses there at the top of that image of the rising sun. And I'm going to do a semicircle like so. One thing you may remember from a couple of weeks ago is that what we essentially have here is a double square. So if this is one, this is two, and here obviously are the two separate squares. Now, I'll talk more about this in 2 weeks from now, but the square root of 5, geometrically understood, is the diagonal of a double square. So if that's 2, 1, 2, whereas from here to here is that number 2.2360678, goes on and on to indefinite number of decimal places. So this is what we're going to use to get a root 5 measurement. So as you can see, I'm opening up compasses so that I have the point of the compasses here and the pencil at the tip of that petal there. And that gives me that root 5 measurement on my compasses. Now, we won't draw too much with it. I'm just going to make a little mark down here. So that has brought that root 5 measurement to here. And then I'll come up to the top of this petal here and make an equivalent mark like this. Now I'm going to use harder lines now, so I've switched to an HB pencil so I can get a stronger line. I'm going to put in this root 5 rectangle. Now, obviously, you can't do this line yet until you've done this top line here, because that's going to help us to find the top corner. So what we have here is obviously a root 5 rectangle, 1 by the square root of 5, 1 by 2.236. Now I'm going to go back to the original measurement. Don't take it off the ruler, take it from your diagram. That's something we always emphasize when it comes to going back to an original measure of some sort. Go with the one that you started with. So as you can see, this is 1. So if we have the square root of 5 plus 1, as you may imagine, I'm going to do this. And then I'm going to place the point of my compasses here. So having put this mark here, I'm now going to make a small mark, which I suppose you could say an extension of this line would naturally pass through. So that defines where you put. So as you can see, a line there would naturally carry on and go through there. And so if we have that, then we can do this. And that gives us the top corner of the square. So I'll just go through that again. First of all, having reobtained my measure of 1, I first did this mark, and then I did this mark here, so it would catch an extension of that line, and then did that. So this is, one of the ways of getting a square when you only have a certain amount of information. The square root of 5 plus 1. Now, divided by 2. Now, for this, I'm going to... Now, just to say, it's going to be somewhere around about this sort of area here. So when you put in your bisector crosses, such as I'm doing now, now you'll notice I'm going to these two ends of the whole of this, the square root of 5 plus 1. So all of that's what is what needs to be divided into 2. Now, having done that one up there, I might as well come down here to these 2 points to do this one. Now, I haven't used any particular measure on here. I've just used a measure that would, I mean, these 2 crosses can be anywhere really, so just dependent as long as they're outside of the main rectangle area. So that you can use any, well, all sorts of different measures for that. I'm not going to put the whole of this line in. I'm just going to And so there you have a golden rectangle. 1, 0.618. Now, there's a particular quality that the golden rectangle has, and this is quite a sort of well-known image. You see this in various places. If you take a square away from a golden rectangle, what you have left is also a golden rectangle. Now, you can see that from the fact that the relationship of 1.618 to 1 is the same as the relationship of 1 to 0.618. Now, bearing in mind that this is 1, I'll also put this one in so that we can have the same thing on both sides. So there again, you have golden rectangle, square comes off, you have another golden rectangle. Right, now we've got this. Let's put pinprick holes through. I'll show you the points we're going to use. Turn the paper over and we'll do another sort of diagram that uses this, that puts the golden ratio spirals in. This is so sort of well renowned with this particular type of rectangle. So the places where we want holes, as you can see, are the four corners of the whole form. Also top and bottom of this line and the equivalent line over here. And then also this dotted line, we want the top and the bottom of, well, where the dotted line goes through these rectangles. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what I'm going to recommend here is that you draw in all of the vertical lines first, and then put the two horizontals in. Because if you put the horizontals in first, your pencil line sort of covers up all of your pinholes, and you can't see where to go. So having done those ones, I'm now going to right, let's begin by putting point of the compasses like so. And we're going to go to that one measurement again. You should obviously find that it's both ways. I'm going to do an equivalent one over here. Right, having done those, I'm now going to reduce the size of my compasses, and I'm reducing it by the golden number. Oh. Right, to give myself the position for drawing, I'm going to make a little mark there, and then come across to the equivalent place on this side and do a mark there. Now this obviously is going to give us a square, because as you can see, it's the same measure, like so. And this is a point where the two spirals meet before they then spiral away again. So those two arcs, as you can see, were drawn with the point of the compasses in these 2 points here. Yeah, there and there. Right, I'm now going to take this measure. So again, decreasing by the golden ratio. Mark like so, and a mark like so. So a little mark there, and a little mark there. Perhaps I'll just do them a bit more strength so you can see them. And then I'm going to go to here, having put those marks in, and make the same marks up here as well. Now again, reducing by the golden ratio. Now I'm gonna, as you can see, I'm just gonna make 2 marks here. This is all we need. Now, something that inevitably happens when you're human, as I am, is that this gradually starts to go out, and mine has already gone out a bit. I'm gonna sort of make mine a little bit. So even though this does work, I suppose you could say, as a mathematical reality, when it comes to the drawing of it, it's subject to the imperfect human hand. So my golden rectangles are perhaps not quite so golden as they started off, but so be it. If we don't do the drawing, we won't be reminded of the ideal form. Now, thanks for joining me, everyone. I'm going to just mentioned some of what I've mentioned in previous weeks. This is a course that I'm running about my book and about geometry, cosmology, and spirituality in the design of the cathedral here in the city of Wales, where I live. There's going to be labyrinth walking, as well as the drawing and the talks and the cathedral tours. And we'll also be walking the Venus pentagram and octagram. You're welcome to come to that. Another one that I'll be doing very soon in early February for the Fintry Trust, which is a wonderful retreat centre or sort of house over near Godalming. And so the next session, it's back up to being a bit late again, 10:30 p.m. if you're in my time zone. But please do come along, and if you can't make any of these sessions, they all end up on my YouTube channel anyway. So do come along next time. I'll switch my camera back on to say goodbye. Thanks for coming, and I shall
Thank you, Tom.
see you next time.
Thank you, Tom.
Thank you. Thanks for coming.
Thanks so much.
Thank you.